Okay, so here we're going to try to figure out the base height, the base radius and the height of a cone if I take out this chunk out of a circle here, fold the ends together, and I get a cone. If I do that, then the slant height here of my cone is going to be the same as my radius of my original circle. That's where that comes from. And then the height I need to figure out by looking at this circumference here. This circumference here is equal to the length of the major arc here, because that's where it comes from. I take these two ends and I join them together. So once I know the length of the major arc, I can figure out the circumference of my cone. To do that, it's just going to be what I did last time. Circumference is going to be 2 pi r, which in this case here is going to be 20 pi, just like last time. But I only want that portion, the major arc portion. In other words, I just want to do 310 degrees out of the 360 times 20 pi, which again is 155 over 9 pi. So that's the circumference. That's the length of the major arc here. That's the major arc, which is the same as the circumference on my cone. Okay. Now, looking from a top down, if this is the top of my cone, okay, my cone looks something like this. Okay, and I'm trying to find this value here, the radius. Well, I know what the circumference is. There's a circumference right there, and we know that circumference of that circle is related to radius by circumference equals 2 pi r. Or in other words, radius is the circumference divided by 2 pi. So if we're to do that, that would be 155, what that says, 155 pi over 9 times 1 over 2 pi, which is the same as dividing by 2 pi. Okay, you work out that, and that'll give you your radius. Okay, the pi's cancel out there and there, and you get 155 over 18, or 8.6. Okay, so that's going to be my my base radius. Okay, so in other words, that would go right here. This is 8.6. Then I have a right triangle here where the hypotenuse is 10, one leg is 8.6. I just need to figure out what that is, and I can use Pythagoras theorem to do that, and I'm sure you can do that on your own. So that's how you solve the cone problem.